This is another video tutorial in the series on advanced spring design, brought to you by Universal Technical Systems and the Spring Manufacturers Institute. This session, we'll take a look at designing a spring made up of two spring segments arranged in series, coiled continuously. We'll be using round wire. Make the selection in ASD. We'll tell it the wire size. We'll tell it the coil diameter. By default, we see that equate coil diameter is set, which means that both ends will have the same coil diameter. This program includes a transition region defaulting to one active coil, and that goes between the two different end conditions. We'll say that one end of the spring will go solid. This will be the point at which the rate changes, and we'll say that that happens at 15. We'll say that the entire spring goes solid at 45 pounds. At this point, enough information is available to define the transition region only, but we don't have enough information for the two ends. We don't have enough information specifically to identify how many coils there are on both ends. Now we could input those, or we can go to the Loads tab and we can give it some more information. We'll say that initially the rate of this spring is 20 pounds per inch, and after end one goes solid, the rate will change and it'll double. We need it to go to 40 pounds per inch. At that point, the design is complete. We see that it is able to compute the free length, the various lengths at different load points. We could specify a cycle load of say 7 pounds, another cycle load 37.5 pounds. We get the associated deflections and stresses there. If we go back to the Geometry tab, we see that the number of coils has been computed. We can get a view of this in 3D. We can see that the end that goes solid first has a smaller pitch than end two. We can go to the Plots tab and we see how the rate changes. We see the deflection load plot and the height load plots are nonlinear now. They change. And the stress plots show the initial stress until the first segment goes solid. At that point, no additional stress occurs on that one. The next transition point is where the transition region, that coil goes solid. And then finally we see the stress on end two, which remains active until the entire spring goes solid. So you can use ASD nicely to model springs with variable pitch and nonlinear spring rates using modules such as this one.